In this video, we're going to move on to the alkyne hydrocarbons, so the ones that start or have Y in the name. And for alkynes, we're looking at hydrocarbons that have at least one carbon-carbon triple bond. So we went from alkanes with single bonds to alkenes with double bonds. Now we've got alkynes with triple bonds. Our general formula is CnH2n-2. So to go from the double bond to the triple bond, we have to lose 2 more hydrogens. So we're going from 2n down to 2n-2. So same process as we did for the other sets. If there's 6 carbon atoms, we'll do 6 times 2 minus 2, which is going to be 10. So 6 carbon atoms must have 10 hydrogens. 8 hydrogens has to be equal to the 2n-2, which means we're going to have 5 carbons. If there's 9 carbons, 9 times 2 minus 2 is going to be 16. And then 32 equal to 2n-2 will be 7. So for drawing alkynes, same process as before, but now we're going to make sure we've got a triple bond somewhere in our molecule. So just like with alkenes, we're going to connect our carbon atoms with single bonds. Then we will put in a triple bond somewhere. And again, all we have is a formula, so it doesn't matter where. Then fill in the missing bonds with hydrogens, and you should end up using the correct number as long as all your carbons have 4 bonds. So if we do the first example, we've got 6 carbons. Put your triple bond anywhere. I'm going to put it on the end. So if I look at this first carbon, it already has 3 bonds, so it's only missing 1 hydrogen. The next carbon over already has 4 bonds, so there's no hydrogens. Then the next 3 all have 2 bonds, so we're missing 2 hydrogens. Then the one on the other end only has 1 bond, so it's missing 3 hydrogens. Next example, 4 carbons. This time I'm going to put the triple bond in the middle. So the carbon on the left needs 3 hydrogens. Both of them in the middle already have 4 bonds. Then the one on the right also needs 3. So there are these 6 hydrogens. Go ahead and pause the video and see if you can draw an alkyne with 5 carbons. All right, 5 carbons. Put the triple bond anywhere. I'm going to place it here. Yours could be somewhere else. The left end needs 3 carbons. The next one needs 2. The next 2 with the triple bond both already have 4 bonds. And then the one on the other end also needs 3. So if we check our 2n-2 for 5, so 2 times 5 minus 2 is going to be 8. And it did indeed take 8 hydrogens to draw that structure. If we're going to talk about 3-dimensional shape for alkynes, here is the triple bond. And now notice we're going to count bonding groups. If we have this carbon, we've got 2 bonding groups, and 2 bonding groups is linear, which is what we have. So we've got this 180-degree bond angle now, which makes it linear. Again, if we look at the single bonded carbons in the molecule, all of those are tetrahedral like we would expect. For physical properties, our alkynes are going to have a slightly higher boiling point than the alkenes and alkanes. So it's going to actually be higher than an alkane, which makes it the highest overall. Now we said alkenes have a lower boiling point than alkanes because we lose 2 hydrogens. Going to an alkyne, we lose 2 more. So you would think the alkyne would actually have the lowest boiling point, not the highest. But if we look at that structure, we had the very straight structure, and that allows for a lot of stacking and interaction and with London forces. So that puts the alkyne at the highest boiling point. So down here at the bottom, we have our ranking. Alkynes are the highest. Alkanes are in the middle, and alkenes will be the lowest. And remember, if we have cis and trans to compare, cis is lower than trans. So here's a couple examples where we're going to rank boiling points. All you're given to start is a formula, so you need to decide, is it an alkane, alkene, or alkyne first? And the way you can do that is using those general formulas that we learned. So the ANE, the alkane, is the 2N plus 2. The alkene is the 2N, and the alkyne is the 2N minus 2. So the first example, if we have 5 carbons to get to 10, that's going to be the 2N, so that means this is an alkene. The second example, 5 carbons and 12 hydrogens. To do that, we need 2N plus 2, which makes it an alkane. And then the third one, we have 5 carbons and only 8 hydrogens. So that combination is the 2N minus 2, making it an alkyne. So our ranking puts the alkyne as the highest and the alkene as the lowest. So pause the video and see if you can rank the second set of hydrocarbons here. All right, the first formula, 8 to 18, requires the 2N plus 2 formula, making it the alkane. The second one, 8 to 14, is 2N minus 2, so this is the alkyne. And then the third option, 8 to 16, that's 2N, so this is the alkene. So again, our ranking, alkyne is the highest, and alkene is the lowest.